Bismillahir Rahmanir Rahim. My name is Ihab, a student in Sheikh Jamran University of Ahwaz Faculty of Engineering, Computer Engineering Department. Title thesis on energy efficiency and reliable protocol for IoT, Internet of Things. The thesis submit in partial fulfillment of requirement for the master degree. We focus supervisor Dr. Muhammad Jawad Rishti. We focus in this presentation the most important subject of the thesis headline. This introduction, this include introduction, problem statement, related work, methodology, result, conclusion, future work. Introduction. Internet of Things is very large scale. Scale complexity such as radio frequency, cell phone, and sensor relative information environment. In Internet of Things environment, routing protocol for low power, loosely network, called RPL, custom design. In RPL, each node select the node as the parent from among the node closest to the sink. This process destines a hierarchical structure between these nodes. In this research, an approach determines the objective function presented, which in addition the ring of parent, energy consumption, and link quality along ETX parameter, expected transit count. Problem statement. The Internet of Things in a cloud, low power, loosely network, along with devices that have a limitation on processing power, storage capacity, and other resources. The routing protocol chosen for such network should be take into account the energy requirement of the sensor node as well as the nature of the lag communication, such as RPL routing protocol. RPL serves other protocol. It applied to be used in the implementation of the RPL protocol to application such as the smart grid increased. The discussion objective function determination. The RPL protocol is still an open research discussion. Therefore, in goal, the purpose approach for each node to select variant from among candidate variant to send it packet that has the maximum energy lift with this approach and ETX criterion. Purpose of research: increase live the network using the residual energy consumption criterion of the nodes, increase reliability, and reduce the number of packet losses using the ETX criterion. Evaluation in conversion the default RPL function of the standard algorithm using QG. Routing protocol related work. Routing we start related work. Routing protocol for low power and loosey network. RPL is a distance factor routing protocol designed for to work on multiple layer above multiple layer in cloud, and Mac layers. The protocol designed using the lower low power lossy network element. Key feature in RBL that special routing solution, low power and conception network. The purpose of a protocol network where nodes predictably send the measurement made to collection point, as well point to point, point multi-point. RBL is based on topology DAGs, direct acyclic graphs. The DAG definition a tree structure, specific default paths between nodes. A DAG structure is something beyond the typical tree in the sentence that one may be linked to multiple parent nodes in the DAG, unlike classic tree where only parent allowed. The RBL organized node a destination DAG do DAG, where the popular destination node sync gateway. A network may choose consist of one or more DAG, two that together from an RBL instance identifier by an Q identifier called an RBL identifier. An example of RBL symbol with DAG. This RBL one, RBL2 instead. RBL consists DAG consists DAG. This structure DAG. This communication multi-point to point. This point to multi-point. This famous between the communication. RBL offer the following feature: automatic configuration, self-healing, prevent loop detection, independence, and transparency, multiple edge routers. RBL message type. RBL message type. For DAG information object DIO broadcasting route to the node. DIS DAG information status. This message broadcast from new node to the root. Everything objective DAO. This message is used to send path information from nodes to the root. Destination advertisement objective and acknowledgement DIO. This message is issued by DIO, required as DAO message verification and contains information such as DAO sequence, RBL instance, and status. Related work. This figure RPL control message and control message new DIS route node DIO new node DI broadcast route node and their related work. One of the key concepts in the objective function. This is important. Objective function. This function carries the metric open which nodes select the better parent among computing nodes. Objective function default depend on the select parent on the rank. There are two objective function: objective function 0 and objective function MRH objective function. Objective function 0 Methodology review method. The RBL routing protocol uses the tree structure. In this structure, node placed in the form of parent and child, which create a hierarchical structure. To create this structure, the sync first broadcast message to in which the number of hubs is set to 0 in the network open, receiving this message. Each node, if there has no already receiving it, added the number hubs in the message +1 and save it is ring. It will then send the message to all this neighborhood, but if it has not receiving the message before, it compare its ring with the jump value. Is the message if the node ring is less than the hub value, the node ring will be updated. Otherwise, ignored and drop. For each node, the lower ranked neighborhood create a set called candidate variant. When selecting the next node, each child node must select one of candidate variant for the packet to the sync. The development of the RBL routing protocol have defined a station called the objective function that allows different applications use the objective function to select the parent for each child node. The approach gives RBL protocol flexibility to use into variety application. The standard RBL protocol use objective function, this mean and number of jump. This causes other parameters such as energy parameter nodes, the quality of communication link, latency, the amount of environment nodes. This ignored. Therefore, in this research, by considering other parameter in addition to ring, we try provide an approach that can be create more optimal path for data transfer between nodes and the sync. Proposed method. In the proposed method, which is the proposed expected that the nodes participating in the routing are selected from among nodes with high energy level and thus increase life the network. In addition, proposed approach uses the criteria which ETX criteria. This therefore it to be said proposed method seek full to goal. Increase the lifespan grid lifespan using the node residual energy measure, increase reliability and reduce the number of packet losses using ETX. This example for the candidate variant as show figure 1 for node as therefore node 20 there are 4 candidate variant: 18, 13, 19, 16, 19. This we fewer jump than 20, which include there are 20 will use the 16 information to send the information, because if you jump to the sync node, it should noted the measurement node 19 may also choosing the 16. It's barren because the path that passes through the 16 is quickly energy lose it is energy and become a hole. In fact, flowchart in the RPL protocol there is a timer called trickle timer, which is responsible to update the structure of the network graph. This flowchart started a create parent candidate list based on link, gather the link information between the node and candidate parent, gather candidate parent remained energy from parents with less rank, select parent with max remained energy and paste ETX link end. Evaluate result. The experiment performed in the environment with the condition item characters. This characters. Simulator. The simulator in Kuja. Kuja simulator is an simulator our evaluator embedded in the Contiki operating system. Contiki is an open source operating system for network system with limited memory. Common IoT protocol wireless standard a network built in Kuja by default can be used to improve performance. Language in Kuja C++. This network and this network we can use in implementation. In order evaluation, the proposed approach, the network consists 15 typical, because 15 typical work previous normal environment select from 10 to 25. The sync node and the 15 node. The range of transmission and interference TX and TX range. This green 15 meter and gray 100. This evaluation are always based on different parameter. The parameter average delay, successful delivery rate, and energy consumption. The average delay time is taken from packet from the transmitter node to the reach server. Successful delay, how many packets sent by the sender have been successful received by the server. Consumption, energy consumption, how much energy did the network nodes. This radio on consumption on the nodes, node 1, node 2, node 2, consumption energy in transmitting node and receiving node RX. We use simulation in 20 minutes. The evaluation to scenario 1 We use simulation time 20 minutes. The evaluate two scenario. Scenario one, first scenario, the amount of environment loss for each node in each jump is 0.2, and the result, the probability of sending a packet jump 0.8, and second scenario loss 0.4, and probability of sending successful 0.6. This evaluate result in parameter. Latency is one of the most important parameter is measurement the quality of the method provide in the Internet of Things and any method presented in this area tag. This delay average, and we show this different conversion of average packet latency in the first scenario, probability successfully 0.2 between propest method and paste method, and scenario 2.6, second scenario 0.6. We have very different between this, and the results show the method for packet delivery less delay. The use of link quality parameter, which considered in propest method for selecting the variant of each node, has led to reduction in packet sending delay. Another point that can be seen in this figures is that as the packet loss rate increased, the difference between the delay, the propest method and the paste method increase. As a result, it can be said that the propest method work even better than compared in the work with higher loss. Delay packet delivery rate network multi-jump approach is used to deliver packet. This means that the nodes jump although each other to send packet to the sink to the receive by the sink. This reaching the likelihood of receiving packet by the sink exponential. This we show this different in the packet delivery rate. This increase in the propest method. Conversion successful in first scenario 0.28 and 0.6 second scenario. So much difference between figures is due to increase loss rate from 0.2 and 2.4 as well. Now due to multi-hop nature of this network, by a few increase loss rate, the packet delivery rate decrease exponential. Evaluation result. The results show that propest method in the successful delivery of packets also act better delay. The first scenario difference exponential to 0.2. The packet and delivery the sync higher, and the second scenario 14.14 increase 0.14. This show that propest method work better than the paste method. in higher loss network. The better performance of the purpose method in this parameter is due to the use of link with the better ETX. Energy consumption. Amount of energy consumption of node result of the amount energy consumption different parts the node processing, transmitting, receive, idle power consumption. This here power consumption macro joule. This energy consumption different parts in nodes. In first scenario proposed method and basic method. Here conversion energy consumption first scenario point and second scenario consumption. We show in this value result. The first point is that most of energy consumption of the nodes has been in dormant state, so that it can be seen in the form means related the energy consumption of the different parties, that the total energy consumption approximately equal the energy consumption in the sleep mode. The second point to be drawn from these figures is that in all scenarios the total energy consumption by both methods almost the same. In fact, none of the methods energy consumption. Conclusion: in this research an approach to determine the objective function is presented. The proposed approach is evaluated in comparison with the default RPL function of the standard algorithm using Kuja simulator. The result evaluate in the from parameter of delay probability successfully delivery of packet as well as energy in the form to scenario based on the probability of successful delivery show that the proposed approach has been able to show much better result than the method compare. Future work, they seem that the issue of determining the objective function in the RPL routing protocol can still be considered as the hot research topic in the future. In addition, the result of this study show that considering the like parameter can have significant impact on improving that performance of the protocol. Therefore, we propose to research interested in this field to combine a new parameter from different layers, such as MAC layers, such as buffer length, our transport layer, such as reliability, to provide a new target function for the RPL. Thank you for attention, Doctor.